Hello, today we're looking at spans, spacings, cantilevers and load widths. So this is all the information we need when we want to size up how big timbers we need in order to build certain parts of the house. So we're mainly going to be looking at bearers and joists today. So let's start with spacings. Now, a couple of things. I'll have the title of the section we're looking in up here, so if you need to come back to the video and look through something, you can just find the bit that has the title you're looking for. The first thing we'll look at is spacings, and that is just simply how far apart things are. So the spacings of these bearers, which I've got painted in blue, just from the center of one to the center of another, and spacings are always measured in centers, or center to center measurements. And if we were to go from left side to left side, that would still be the same spacing. Quite often we'll hook our measuring tape onto one side of something and measure across to one side of the next one. And that distance between those, they'll be the same from left to left or from center to center. Around the corner here, if we look at the spacing of the joists, again from center of one to center of the next. So if we wanted to measure out, let's say 600 spacings along there, we'd hook our tape on the end here, and we could just measure from the edge of that 600, 1200, 1800, and that would give us the edge of each of those, or we could just go from center to center each time, and that will give us the same measurement. And then down the bottom here, we've got our post spacings across the width of the building, post spacings across the length. Main thing to remember is spacings are always centers measurements or center to center measurements. So let's look at spans, and there's two types of spans we're going to look at. They're going to be single and continuous. So the first spans we're looking at are single spans, and that is just measured from the inside of the support underneath to the inside of the support underneath. So the span of this joist would be from inside of bearer to inside of the bearer. It is the unsupported span that we are measuring. And then around the corner here, when we're looking at the span of that bearer from the inside of the supporting post to the inside of the supporting post. Now, one key aspect to remember when we're measuring all of these distances, if I go back to our spacings here, if I'm just looking at these bearers, I am measuring in line with my bearers when I'm measuring my spacings. When I come to measure the span of that bearer, I'm measuring underneath it. So when I'm looking at a member and looking to size that member, I will sometimes measure in line with it, I will sometimes measure underneath it, and a bit later in this video we're actually going to be measuring things above it, and it just depends what it is we're measuring. So centers are measured in line from center to center. The span is measured underneath from the inside of the support to the inside of the support underneath it. And that is a single span for the bearer, single span for the joist. And here's an example of what I'm talking about. Even though I'm measuring along the same line here, there's my joist span, there's my bearer spacing. Even though if you imagine me running a measuring tape across there, it's nearly in the same line, but just the fact that I'm measuring from center or from inside, it changes what I'm measuring. I'm measuring a bearer spacing there, but a joist span above it there. So let's go on to an example. So here we have a 5 meter wide building and a 6 meter long building. So if I were to take away the thickness of my timbers, which I've got drawn there, width of my building minus the thickness of my bearers would give me an inside measurement or a joist span of 4850. And then the same around the corner here, I've thrown a couple of 75mm stumps under the bearer. So the length of the bearer might be 6 meters, but the span of it is only going to be 5850 once I take off the thickness of my supports. So that's a bit of an example to have a look at. Let's look at continuous spans. I've thrown an extra bearer in. There's an extra stump in. So this bearer now continues over a middle support. So you can see our spacings are measured the exact same way. Center to center for our spacings, center to center of the joists of the spacings, no change there. But our span again from inside of support to inside of the support. But because that bearer here continues over into a new span with one piece of timber with more than one span, that becomes a continuous span. And the same for this joist. This joist now is touching 3 joists, which means it's got 2 spans, and in fact it could even be longer. If that joist was very long, it could be 4 or 5, as many spans as that single piece of timber can go across. So here we have 2 continuous joist spans because it's the same piece of timber going across. So let's throw an example in. Here we have the same width of building, 5 metre wide, 6 metres long. We're going to take away the thickness of our timbers, and that leaves us, if you do the maths, that leaves us with 23/870. I'll probably round that off. I don't really work in half millimetre measurements. I usually round off to the whole millimetre. I would call that a 23/88 continuous span. Same there. And around the corner, if we take 6 metres and take off these, that leaves us with a 28/87.5 millimetre span, continuous span, under both of them. And of course this is assuming that everything is evenly spaced. If this post here was slid up a little bit, I would end up with one small span and one big span. But let's just assume everything is evenly spaced, because usually it is where we can get away with it. So one of the important things to remember is whether our span is single or continuous, and there's a reason for that, because it affects the sizing of our timber. If I use this as an example, I'm going to throw a couple of measurements. So we've got 2 different setups here. Here is a continuous span, but from one support to another we've got a 5 metre continuous span. Here we have a 5 metre single span. So both of these joists are spanning the same distance, even though that one continues over. You'll notice that this joist is bigger than this one, and that's deliberate. That's because a timber that continues over to the next span, one side of the timber helps to support and strengthen the other side of the timber, and therefore can be slightly smaller than a piece of timber that spans the same distance only as a single span from one to the other. This has nothing on the end helping to support that deflection, so this needs to be slightly bigger to span the same distance. And that's why it's important always to remember whether we're working continuous or single spans. It changes the size of timbers when we're looking in the span tables. So let's look at cantilevers now. So if we move this bearer in, you can see our joist. This is still a single span here, but it continues past and just hangs over on the end, and this is a cantilever. And a cantilever is always measured again from the outside of the supporting member underneath through to the end of the timber where it finishes, and that's called the cantilever distance. If I move these posts in, now my bearers are also cantilevering, which is measured from the face of that post to the end of the timber. Whenever you have a cantilever, the next span that is in behind it is always referred to as the back span. And there's 2 things that affect how far a piece of timber is allowed to cantilever. One is the size of the joist, or the size of the piece of timber. In this case I'm looking at the joist. A bigger piece of timber is allowed to cantilever further, but it's also restricted by the size of the back span. The smaller the back span, the smaller the cantilever has to be. So those 2 things, the length of the back span and the size of the timber, both affect how far is allowed to cantilever past there. So there's our titles, there's our cantilever distance, there's our back span. This is still a single span in this example, but it's also the back span. So if I get rid of all of those joists and just leave the bearers on the posts, and I label everything that's in here, you can see, because of how long this bearer is, I've got 1, 2, 3 continuous spans across there. I've got a cantilever on the end, but this span on the end here, the first span in behind the cantilever, is also the back span, which is attached to that cantilever. And just for the sake of example, if I were to run my power saw through here and cut that bearer right through there, I've now changed this to a single span. And if that were to happen on a job site, you would have to check the span tables and make sure that that size timber is actually allowed to do that distance in a single span, or whether it has to be a continuous span for that size. Let's go on to load widths. Now load widths can get a little bit tricky. So if we look at this example here, when we measured our spacing, we were measuring in line with whatever we were measuring, so our bearer spacing was measured in line with our bearers, or at the same height as our bearers. Our joist spacings were measured at the same height as our joists. When we measured our span, we had to measure underneath what we were looking at. So this bearer, the span was measured underneath the bearer from post to post. Now we're measuring above. So we're measuring a load width, and in this example I'm going to look at floor load width. There's also a roof load width, which I'll touch on a bit later. So let's look at these two bearers. These are the ones we're working on. I want to know how much, basically how much load or weight is sitting on each of these bearers. So if you look at this joist along here, half of this joist is sitting on that bearer and half of it is sitting on that bearer. So that makes things nice and easy. So if I have a 5 metre wide building, half of that 5 metre floor load is sitting on that bearer and the other half there. So I've got a 2.5 metre load width on that bearer, 2.5 metre load width on that bearer. And you'll notice it's measured from the very edge of the building, from the very outside to the very outside. Now the thing to remember is it's not just half the building, it's halfway between the two supporting members that I'm working on. So if I were to move this bearer over, I now have a cantilever on one side. I'm still going to be measuring halfway between these two bearers, which means this bearer is also taking the cantilever. So in this example, there's the full width of my building. I've decided to make this 5 metres. I might have a smaller load width there and a larger one here, maybe possibly a 2 metre load width and a 3 metre load width, depending on my dimensions. And that's because each bearer is taking the load halfway to the next bearer, but this particular one is also taking the cantilever that's over this end. So that means if I cantilever on one end, I could end up with a larger load width on one bearer. And this is floor load width. So just the weight of these joists and the flooring that's on it. Let's look at a slightly different scenario, still working on floor load width, but you can see we've got an extra bearer in the middle. So this is going to get a little bit different. If I measure, again, halfway between each of these bearers, so these dotted lines are halfway between each bearer, you can see this bearer is only taking just halfway to that centre bearer. Same with this one, this goes from the outside to halfway to that next bearer. This bearer in the middle is taking halfway to that one as well as halfway to that one. So this central bearer has a bigger load width, or bigger floor load width, than these two outside bearers. And if you imagine this joist being a lot longer and multiple bearers being in underneath, that floor load width would be the same. It would be bigger in the inside, and then the two end ones would be slightly smaller. So that's floor load width dealt with. Now we're going to look at roof load width. So I've drawn a couple of bottom plates here. So I've left the wall frames out just so that the drawing doesn't get too complicated, but if you imagine a roof sitting up here, sitting on two walls, coming down onto these bottom plates. So these will be the bottom of two load-bearing walls, and the roof will be sitting from one to the other. So you can see now, you're probably already anticipating that half that roof load will come down onto this side, and the half will come down onto that side. You'll notice we're not looking at roof load that's sitting on these joists, because that joist is supported straight underneath by the bearer, So right now we're only worried about the roof load that is sitting on these bearers. And of course you can imagine if this building is 5 metres wide, then half the roof load will come down onto this bearer and half the roof load will come down to that bearer. So I'll throw those measurements in. This central bearer is not taking any roof load at all. So even though that was taking more floor load than the others, it's not taking any roof load at all. Not in this example anyway. So you can see 2.5 metres of roof load on that bearer, 2.5 metres of roof load on that bearer, providing that this is a 5 metre wide building. Always be careful of overhang. So most roofs have an overhang on the end. So if there were, for example, another 600 mil of overhang on this roof, that would add to the roof load, because the roof may not finish in line with this wall. It could have extra overhang on either side, so that would increase the roof load sitting on these bearers. And here I've just drawn one of the measurements that we had previously. This in blue is the floor load that was sitting on this bearer. So you can see this bearer is taking 1250 of floor load plus 2.5 metres of roof load, and if this were to have an overhang it would be even greater roof load because of the overhang sitting on the outside. Let's throw a couple of bottom plates in this way. Now, not many jobs have this situation, but you might come up with one where you may have a large skillion roof that spans from this end wall all the way through to this end wall in one hit, in which case these joists would be taking some roof load. And we would measure that in exactly the same way. Half the roof sits on this wall, the other half sit on that wall. Let's presume this is a 6 metre long building, and there you would have 3 metres of roof load sitting on each joist, running along there and running along there. I've left these measurements down the bottom here because it's getting a little bit untidy up on the drawing up here. One thing to remember is, even though I've got this drawn measuring from that corner to that corner, I'm not actually measuring necessarily along this bear or anything. I'm only measuring roof load sitting on the joist. If I were to take that measurement in here, it would be exactly the same. It's just the distance of roof that's sitting on this wall and the distance of roof that is sitting on this wall. In this case, it's just half and half. Now this, of course, is only if this roof actually spans from there to there in one hit. Most standard constructions, that's not quite the case. In fact, let's go to a drawing like this for a slightly more potentially realistic construction for a roof load. Here we have a standard hip end roof, just a nice rectangular building. I've thrown in 2 bearers and a bunch of joists going across. So I'm using the same colouring that I had previously. This black line is just the roof line. Let's throw a couple of measurements in just for the sake of example. Let's say we've got a 6 metre long building and a 4 metre wide building. One of the things to remember is these joists in the middle here, they're not taking any roof load. So I'm just going to get rid of those joists to make things a little bit clearer. So we're not worried about those joists. We're just worried about the amount of roof load that is going to be on the ends of the building sitting down onto those joists. So the next thing I'm going to put in is the roof framing. So I've just drawn in some trusses in here. They just span in one hit from one wall to the other wall. I haven't drawn the wall in, I've just drawn the bearer in just so that you can see what it's coming down to at the bottom. You'll notice these trusses have a dotted section. That's because these are the truncated trusses. They come up the rake of the roof, they flatten out a little bit along there, and then they go down the rake of the roof there. And that little flat part of the truss is just to make this hip end work. So we've got 2 truncated trusses. So let's have a look at this one on the end. That truss there is taking the roof load from that bearer all the way through to that bearer. When we make up the hip end, we'll run some timbers from that across, and I'll throw them in. So here we have some jack rafters or jack trusses as the case may be, and they go from there across there. So this joist is only taking the amount of roof that is halfway to the next thing that's taking the weight of the roof. So if you just look at the distance from that joist to that truncated truss, the amount of load width sitting on that wall which comes down onto that joist is only halfway to the next support. So you can see, even though this is a 6 metre long building, in this case you don't have a 3 metre load width sitting on that, because these trusses are actually taking all of the load onto the bearers. And so this joist at the end, it may have an extremely minimal amount of roof load width coming down and sitting down on top of it. And in fact it might be so little that even just a double joist might potentially be enough to take that amount of load. And that's a very common construction technique, is to throw a double joist on the end just to take that tiny bit of roof load on the end of there. It also helps with nailing wall frames into it. So, a quick summary of everything that we've covered so far. We've looked at spacings, which are measured centre to centre and at the same height of what it is we're measuring the spacings of. So our bearer spacings are measured at the same height as our bearers from centre to centre. Our joist spacings are measured at the same height as our joists from centre to centre. We've covered single spans, which are measured underneath. The single span of this bearer is measured underneath from inside of support to inside of support. And in this example, the continuous span of this joist is measured underneath, in between the supporting bearers. We've also looked at cantilevers, measured again. The cantilever of this bearer is measured underneath from the face of the support to the end of the bearer. We've looked at our back spans, which are the next span in behind the cantilever. We've looked at floor load widths, and as you can see, we've got floor load widths that aren't exactly the same for each of those bearers, because some are on the end and some are in the middle. And we've looked at roof load widths, which come down the walls and onto the top of our bearers in this drawing. Thank you very much for your time, and good luck.